So I hope you've been enjoying learning the new song, which I do think is my best work, to that country classic, She's in Love with the Boy. And what the purpose of this next few minutes is for you to check your work on your song questions. And also I need to teach you a few key concepts that were not part of the song that I just could not work in. So as you check this out with me, the name of the scientist we know that published that paper explaining where the continents started, that was Alfred Wegener, the scientist you met, and the name of his theory was continental drift. Okay, so over yonder in Germany, a man named Alfred was shocking the world with his continental drift theory. Now, in the first chorus, we really sang the two-word summary of continental drift, that Pangea split. Okay, so that is really the summary of his theory. It's okay on your quiz to explain continental drift in those two words. Now, number 4 is a super important question. The song mentions 3 different pieces of evidence that continental drift happened. So some people think, oh my gosh, Alfred Wegener, this crazy guy, he didn't have any evidence to support his claim, and that is not true. Here's how we know. Remember in the beginning of the song, it says, tropical fossils sitting in Greenland. That's weird. Tropical means hot, remember? Why would you have tropical fossils in Greenland? Well, you'd only have that if Greenland hasn't always been where Greenland currently is. We know we also see tropical fossils in Ohio, too. Now, the song sings about glacial grooves are all a mess. What I mean by that is these erosion marks, these deep erosion marks called glacial grooves that scour the land, that they actually would match across continents. That's weird, unless the continents were together when the glaciers came through. And then another thing from the song, when we sing It's a Perfect Fit, we know from our Pangea puzzle that the continents' coastlines fit together. So those are the 3 things from the song. Now, what did Alfred name the supercontinent? Of course, he called it Pangea. That means all lands in Greek, so it's a name that made sense. And then number 6 is a really important question. What was everyone's problem with Alfred Wegener? Why was he a laughing stock when he froze to death in Greenland? And the answer is he couldn't explain how the continents moved. He just made something up. He couldn't explain the force that caused them to move. Well, now scientists know that force is magma. So in the song, when it says, in the water at the mid-ocean ridge, the answer was there, magma spewing out the submerged mountain and cools into new ocean floor. Well, my students, that's the first part. Magma comes out at the mid-ocean ridge. That's not enough to explain what happens for seafloor spreading. How did the seafloor actually spread and move the continents out? Well, that magma has to cool, and it's more than that. That new crust behaves like a chisel, and it pushes the old crust away. So really check your work there on number 7. You must have magma, you must have mid-ocean ridge, you must have the word cools, that once the magma cools, the new crust pushes the old away. And of course, remember this part, and if magma stopped flowing one day, the continents would just stay. So that's what you should have for number 8. Then the last stanza of the song, we started to sing, now a new name for an old theory. Plate tectonics is the term. So what I mean by that is the old idea is continental drift. Now the modern spin on it is called plate tectonics. And it explains that the solid lithosphere, that's number 10, squirms above the jelly-like asthenosphere. And then there are 3 possibilities as these tectonic plates move. They can push, pull away from each other, or slide by each other, kind of like bumper cars. So that's checking your work on the questions. Now you're going to be typing with me what you hear for 4 key concepts. So one thing that I found historically with students that is confusing is, what's the difference between plate tectonics and a tectonic plate? So let's start here. Plate tectonics is actually the combination of 2 ideas. So I want you to type on that line, continental drift, and then plus seafloor spreading. You don't have to add this part if you don't want to, but continental drift explains what happened, that Pangea split. Then in the 1960s, when they figured out what was going on underwater at the mid-ocean ridge, seafloor spreading answers how. Alfred Wegener had been long passed away 35 years ago or so, but they realized, oh my gosh, he was right. So plate tectonics is a combination of these 2 ideas. Now, what's a tectonic plate then? It's not a combination of ideas. A tectonic plate is a definite thing that we walk on every day. It's a section of solid lithosphere. It's similar to saying section of crust, but lithosphere is a little thicker than crust. And Earth's crust is divided into many plates, you should say. And most geologic events happen at plate boundaries. Now, when I say geologic events, that just means earth science events. So, like mountain building, volcanoes, and earthquakes. And so, check this map out with me. So, as you really study it, I like to ask students if they're looking at Pangea. And most of the time, students will quickly say yes. But then upon further review, so here's us, right? There's that state up north. Here's us, okay? Here's Africa. Here's Europe. Here's South America, Australia. My students, these are the modern positions. So then what are we looking at? Well, we're looking at these dark lines. Those are not showing Pangea connecting. Those are showing the tectonic plate boundaries. So notice that some plates are really little, like this Cocos plate or the Juan de Fuca plate, and some plates like the North American plate or the Eurasian plate, which wraps all the way around here, those are huge plates. And there are three possibilities of what can happen. And we're going to put a symbol with them. So the first motion that we're going to put on our chart is a push. You know the next one. The next thing that can happen is the plates can pull away from each other. And then the final thing that can happen is they can slide by each other, and you get different results based on that plate motion. So where we're headed next is understanding exactly what happens at those different plate motions.